Everyone, welcome to the HSPF training by DSI. This is Anurag Mishra. We're on the video HSPF160. How do I output HSPF model simulation results in text and HSPF binary format? So in the last video, we just ran an HSPF model, but we did not output anything. In this video, we'll output the results in text and binary format. So let's look at the simple UCI file that it's the same UCI file that we have been working on. So right now, the data is being read from a WDM file, and the run interpreter output is going in an echo file. What we want is a text format output. So let's give it a number 27. It could be anything, HSPF underscore test dot out. So that would be text format. And there's one thing that I want you to note, that I'm using VS Code or whatever software that you are using for text format. When I enter here, it adds these spaces here. In some of the software, it may not add spaces, but it will add tabs. So that might cause some errors later on. Okay, so let's give it a number, 48. It doesn't matter as long as the number is consistent at other places. Actually, it's bino, B-I-N-O. That's the binary format, HSPF underscore test dot HPN. So now we have provided two file names, dot out and dot HPN, and we have given them the file number 27 and 48. So now we have to look at this print info and binary info. For each type of operation, implement, and when you have Perlin and Reaches, you will have these kind of print info and binary info tables. These tables tell that for which operation, so for implement, the operation number 1, what output is going to be written out. So in this case, for iWhat, I'm getting the output. 3 means daily, 4 means monthly, and since it's a 1 month output only, it doesn't matter. So daily output from iWater operations in impervious land, iWater group, will be written out in the text format, print info. PYR means the end of the interval, end of the year actually. So if you have water year ending, you might want to use it end so that it can give you the end of the year summary also. And then binary info, the format for binary info is exactly same. And what I have done here is I have changed it to 2. That means do it the same time interval as the model output, as the model simulation time. Okay, so now I'm outputting impervious land. It can be English and metric unit in the printer. That means text output. It's 27. So let's say, okay, I want metric output just for sake of testing. And I want binary output. This number has to match the number here. So I want binary output in file number 48, which is this. I want printer output in metric unit in file number 27, which is here. Now, if I had multiple impervious operations, I would list them here, and I could make those output go in the same file or in separate files. Similarly, when you have Reaches operations and Perlin operations, you will have exactly the same kind of general information block where you will decide what output do you want to get in a text and binary format. Save it. Now we are going to run WinHSPF. and this is HSPF160 file. So let's run it. Looks like the run finished quickly. So we are going to now look in the folder. And I'll just say date modify so that I can look at the latest file, test echo. So this is the file that tells the run interpreter output, and you can go in to see, okay, the model run did finish properly. Dot out is the text output. So HSPF underscore test out, same name, here it is. So it tells me for each operation, it gives me a report for each day. Remember, we set the output as the daily output. So for each day, it is giving me a report and telling me how much rainfall came in from moisture supply, how much was surface runoff, and as you can see, just for 1 month, there's big report. And as the model simulation increases, you may be running it for 10, 15, 20 years or multiple operations. This dot out file can become very difficult to handle very quickly. And this is just eye water. You will also have other water quality operations. You can have multiple dot out files, but it is still a little difficult to handle this dot out file. The easier option is binary file, HSPF binary format. Now this file, HSPF underscore test.hbn, I have set up my computer so that .hbn file can be opened with SARA time series utility, similar to the one that I did for WDM file. Okay, so I double click it, and sorry, okay, I go, there are 6 time series. I want to select something specific. Supply rainfall that came in, Saro is the runoff that happened from that. If you don't know what these terms mean, it's very easy to search them on the help manual. Let's look at help manual real quick. C drive, if it's a default installation, this is where you'll find it. And SURO, you'll find SURO at multiple places. We are looking at eye water because it's impervious land. It's a surface outflow. The unit is inches per unit per time step of the model. So what we got here is that it's the SURO. You can also look at SUPY, that is a moisture supply. Click on OK and list. You can make a graph of these 2 time series. It's difficult to understand because they are both on the same left axis and very similar colors, but you can always change. You can go to edit graph and you can change these curves. They're very simple to edit these. So this is another way of getting output. So now we have learned that we can have HSPF output in text format and in binary format. Text format is useful when you want to do quick QA/QC. However, it becomes very difficult to work with when we have more operations and more modules. You can also output in binary file. Binary files are a little easier so that you can actually quickly select very specific operation and a very specific parameter and get the time series output out of it. You can also open HSPF binary file using HSPF bin toolbox developed by Tim Serra in Python. So you have some option that makes binary files easier too. In the next video, we'll learn how to output the data in a WDM format. Thank you.